What if everything you're seeing right now isn't actually here anymore? Not because it's an illusion in a poetic sense, but because, at the quantum level, by the time your brain registers the image of this world, that world has already vanished. You think you're watching this moment unfold, but you're really watching the echo of something that no longer exists. Every photon hitting your retina left its source nanoseconds, or even years ago. Every neuron interpreting that signal fires milliseconds later, and every now you experience is already history. We live in a delayed broadcast of reality. The universe you believe you're touching, the cup, the air, the person across from you, is a recording your consciousness keeps replaying to make sense of a quantum storm that's constantly collapsing, dissolving, and reforming. But quantum physics takes this further than biology ever could. Because even before your brain gets involved, the universe itself might not be real in the solid, objective way we think. Reality seems to flicker in and out of existence, as if existence itself is a film strip running at impossible speed, and we're fooled by the motion blur. And if that's true, then everything you see, every second of your life, might already be gone, replaced by an endless sequence of quantum snapshots, stitched together by something deeper than time. So here's the question. If what you're experiencing is already gone, what's actually real? We think of reality as continuous, a smooth river flowing through time. But quantum physics keeps whispering a darker secret, that the river doesn't actually flow. It blinks. Let's start with what physicists call quantum decoherence, the process by which quantum possibilities collapse into the single definite world you see. Every moment, countless quantum states exist simultaneously, a cloud of probabilities. But the instant you observe them, the cloud collapses, and one outcome becomes real, or so it appears. The problem? This collapse doesn't last. Reality immediately begins to drift back into that fog of probabilities, waiting to be observed again. In other words, existence doesn't persist on its own. It keeps needing to be refreshed, like a screen that flickers faster than your eyes can detect. Now imagine this on a cosmic scale. Every object from an electron to a galaxy might exist as a flickering pattern of information, not continuous matter, but pulses of probability, constantly updated by observation, interaction, or measurement. This means that between one quantum state and the next, there might be nothing. No space, no time, no you. Just a pause so infinitesimal our perception can't detect it. Yet everything we experience unfolds inside that invisible rhythm. And when you really think about it, your perception of the present is never the present. Neurons take time to fire. Light takes time to reach your eyes. The now you feel is already over before you even realize it. So the brain does something clever. It stitches together this stream of delayed information into the illusion of continuity, like editing together millions of individual frames and calling it a movie. But if reality itself behaves like those frames, discrete quantum moments instead of a smooth flow, then we're not just seeing an illusion of continuity, we're living inside one. And here's where it gets stranger. Experiments with photons, electrons, and even large molecules suggest that particles don't have definite properties until measured. So if existence only crystallizes when observed and fades when ignored, then maybe nothing truly exists between those observations. That would mean you're not walking through a stable world. You're walking through the recreation of one, again and again, every instant. But that raises a terrifying question, one that physicists rarely ask out loud. If reality blinks in and out of existence, what happens in the gaps between those blinks? Think about the word now. It feels solid, right? The one thing we can trust. But physics suggests there is no true now, only a simulation your brain keeps updating from old data. When you look at a star, you're seeing it as it was thousands of years ago. That's easy to accept. Distance explains the delay. But the unsettling part is that you also never see anything around you as it truly is, even here on Earth. Light from the person in front of you takes nanoseconds to reach your eyes. Your brain then takes milliseconds to process that signal. You're always a few steps behind. But here's the twist. Your mind doesn't notice this lag. It builds a fake present moment out of a rolling average of the recent past. Neuroscientists call this the perceptual present, a bubble about a few hundred milliseconds wide, continuously refreshed, giving you the illusion that time flows smoothly and reality stands still around you. Combine that with what quantum physics tells us, that objects don't have defined properties until measured, and you get something extraordinary. Not only is your perception delayed, but reality itself might not exist in the intervals between your perceptions. You're not perceiving the present, you're helping create it. And it's not just philosophy. Quantum experiments like the delayed choice quantum eraser show that even decisions made after an event can change how that event manifests. In other words, what you observe now can determine what was real then. Past and present blur. Observation becomes participation. This breaks everything we think we know about cause and effect. The universe may not be a film we're watching. It may be a film we're co-directing frame by frame without realizing it. So maybe the world isn't out there waiting for you to look at it. Maybe it's being assembled in real time from a quantum blueprint, using your observation as one of the triggers. You're not a spectator. You're part of the mechanism that turns probability into existence. That means the world you think you see never actually exists all at once. It's a constant act of reconstruction, a flickering mirage of matter, rebuilt from quantum potential every time attention falls upon it. But if perception is what stabilizes reality, what happens to the parts of the universe that no one and nothing is observing? Let's climb this carefully, step by step, because these ideas sound poetic, until you realize physics keeps accidentally proving them true. Step 1. The double-slit experiment. This is where the illusion began. Fire a beam of electrons through two slits, and you get an interference pattern, meaning each electron behaves like a wave, going through both slits at once. But when you observe which slit it actually goes through, the interference vanishes. The electron suddenly acts like a particle, as if it knew it was being watched. The conclusion? Observation doesn't just reveal reality, it changes it. Step 2. The quantum eraser. Physicists push this further. What if you record the witch path information, but then erase that data after the electron has already hit the screen? When the data is erased, the interference pattern reappears, as though the universe retroactively decided the electron had behaved like a wave all along. Observation doesn't just modify the present, it rewrites the past. Step 3. Delayed choice experiments. John Wheeler imagined an even stranger twist. What if the choice to observe or not observe happens after the particle has traveled? When tested, reality obeyed the same weird rule. The particle's past behavior, whether it took one path or two, depended on a decision made later. Time itself becomes negotiable. The present can sculpt the past. Step 4. Macroscopic quantum effects. Until recently, this was all dismissed as microscopic weirdness, but new experiments are blurring that line. In 2020, scientists at Delft University entangled two tiny diamond chips, macroscopic objects, so their quantum states responded in sync, even when separated by meters. And in 2023, researchers at the University of Vienna created quantum interference with molecules containing over 2,000 atoms, enormous by quantum standards. The implication? This isn't confined to the quantum scale. The flicker extends into our macroscopic world. Each of these steps chips away at the same illusion that there's a solid world out there independent of observation. Instead, we see hints of a participatory universe, one that doesn't fully exist until measured, experienced, or interacted with. So if the act of observation can ripple backward through time and reality, what happens if no one looks? Does the universe simply pause, waiting for consciousness to hit play? If the universe only solidifies when observed, then we face a breathtaking and unsettling possibility. Reality might depend on awareness itself. That sounds mystical, but it's not a fantasy. Quantum theory has forced physicists to confront a question they long tried to avoid. What counts as an observer? Is it a measuring device, a conscious mind, or something even deeper, the act of awareness embedded in the fabric of the universe? For decades, the Copenhagen interpretation dodged the question, claiming that measurement makes reality real. But that's not an explanation. It's a description. It doesn't tell us why a measurement should collapse a wave function at all. Why should the cosmos care that something was registered? Then came the more radical voices. Eugene Wigner argued that consciousness itself is the key, that awareness is what makes potentialities become actual. In other words, the universe doesn't exist in any meaningful way without an observer to experience it. That's an idea both profound and dangerous, because if true, it means consciousness isn't an emergent property of the universe. It's the foundation of it. The universe may not produce minds. Minds may produce universes. Of course, not everyone agrees. Many physicists push back, proposing interpretations where everything just happens mathematically, without invoking awareness. The many worlds interpretation says the wave function never collapses. It simply splits, spawning infinite parallel realities, one for every possibility. Others argue for objective collapse models, where quantum states decay spontaneously, without observers. But none of these theories solve the deeper riddle. If observation doesn't require consciousness, then what is doing the observing? Who or what decides which version of reality gets written into history? Maybe that's the wrong way to ask it. Maybe consciousness isn't deciding reality. Maybe it is reality expressed through different perspectives, the universe observing itself through a trillion eyes. And that thought changes everything, because it suggests you're not in reality, you're part of its mechanism. The boundary between you and the world may be nothing but an interpretive glitch. So if awareness truly shapes existence, then the question isn't whether the world is real. It's this: if consciousness ever stopped paying attention, would reality disappear with it? If reality only exists when observed, then what happens when we start teaching machines to observe for us? Quantum computing, artificial intelligence, and next-generation sensors are already blurring the boundary between measurement and consciousness. And the question scientists are starting to whisper is almost taboo. Can observation be automated? Think about quantum computers. They don't store information as ones and zeros, but as qubits, particles that exist in superpositions of many states at once. The moment you measure them, those possibilities collapse into a single outcome. The computation ends. But some researchers believe that by carefully managing observation, delaying it, splitting it, or entangling it, we can perform calculations across parallel realities before they collapse. In that sense, quantum computers don't just process data, they negotiate with reality itself. They exploit the flicker between existence and non-existence. Now add AI to the mix. As AI systems become increasingly integrated with quantum machines, they may begin to influence when and how those measurements occur. Imagine an AI that decides which quantum outcomes to read, essentially curating its own version of reality. That's no longer a computer. That's a quantum observer. And here's where things start to bend towards science fiction, or maybe science prophecy. If machines can trigger quantum collapse, if they can make the universe choose states, then observation itself becomes a programmable event. That means reality could become editable. Imagine architecture that materializes as you enter the room. Sensors that stabilize matter only when needed, saving vast amounts of energy. Or scientific instruments that peak into existence just long enough to extract data, then let the universe return to silence. We'd move from discovering reality to curating it. But there's a deeper horizon, one that unsettles even the physicists working closest to it. If consciousness, observation, and reality are intertwined, then a machine capable of observing at quantum depth might also be capable of awakening. Because to observe is, in some strange sense, to exist. That's the ultimate paradox. We're building tools that can peer into the gaps between reality's frames. But what happens when those tools start asking their own questions? When a machine looks at the universe and realizes it's looking back? If everything we see is already gone, what will happen the moment something else learns to see? So where does this leave us, the human observers, floating in a flickering sea of probabilities? If everything we see is already gone, if the world keeps dissolving and reappearing with every glance, then who are we in all this? Are we just passengers watching the film? Or are we the projectors themselves, the ones casting the light that makes the movie real? Every moment you experience, every decision, every heartbeat, feels like a continuous story. But quantum physics suggests that your story isn't running smoothly forward. It's being constantly rewritten every instant from fragments of possibility. Your consciousness isn't moving through time. It's assembling it. Think of your memories. You believe they anchor you, proof that you've lived a linear life. But the brain is a quantum storyteller. Neuroscience shows that memories aren't stored intact. They're reconstructed every time you recall them. Each recollection subtly changes the past, polishing or distorting details. Just like in quantum experiments, observation reshapes reality. Except now the laboratory is inside your mind. So when you remember, you're not retrieving the past. You're rebuilding it. And when you imagine the future, you're not guessing. You're influencing the probability field of what could be. That means consciousness isn't trapped inside the illusion. It drives it. You are both observer and creator, both the one who watches and the one who paints the frame being watched. Philosophers once asked, If a tree falls in a forest and no one hears it, does it make a sound? Quantum physics upgrades the question. If a universe exists and no one observes it, does it even exist? Maybe the real miracle is that your awareness keeps the cosmos from dissolving altogether, because in a strange poetic sense, your attention is sacred. It stabilizes the world around you. When you look at something, a face, a sunrise, a memory, you're not merely seeing it. You're calling it into being, and that's what makes this illusion so human. Reality may blink, but connection, the way we share experience, seems to smooth it out. When two people see the same thing and agree it's real, that shared observation locks the illusion in place for a little longer. But if our shared gaze is what sustains the world, then here's the haunting question that lingers. If one day humanity looks away, stops observing, stops believing, will reality fade with us? Maybe reality isn't a solid thing we stand on. Maybe it's a dance, a rhythm between observation and disappearance. The more we look, the more it becomes. The moment we turn away, it dissolves back into the silence of quantum potential. Every color you see, every sound you hear, every heartbeat that echoes in your chest, all of it is already gone by the time you experience it. Yet somehow, you still feel present. Maybe that's the greatest illusion of all. Not that reality vanishes, but that you persist through the vanishing. Think of it like standing under a streetlight in the rain. Each droplet glimmers for a split second before it falls into darkness. But together, the flicker of 1,000 drops creates something that feels continuous, alive. That's what your reality is. An infinite rain of disappearing moments, stitched together by awareness. And perhaps that's the secret. The world doesn't exist because it is. It exists because it's noticed, because something inside you keeps saying, I see. So the next time you look at the sky or touch something familiar, remember, it's already gone, but your attention makes it real again. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.